Welcome back to Geometry Classroom. This time we'll talk about congruency of triangles. Congruency of triangles is strongly related of so-called CPCTC. In a previous lesson, we talked about CPCTC. Yeah, what does CPCTC or what stands for? Stands for corresponding parts of congruent triangles are congruent. Yeah, we know a triangle has 6 parts, 3 sides and 3 angles, right? Now, we know in order to prove 2 triangles are congruent, we have to prove all corresponding parts of the triangles are congruent. Yeah? Or, if 2 triangles are congruent, then all corresponding parts of the triangles, which means sides and angles, are congruent. Now, how we identify the corresponding parts? By looking at the names of the triangles. Yeah? For example, remember, a triangle consists of 3 letters, yeah? The name of a triangle. Usually capital letters. Yeah? For example, in this example, we say if triangle ABC congruent triangle DEF, then corresponding parts, their corresponding parts are congruent. Yep. How we identify the corresponding parts? We look at the place of the letters in the name of each triangle. For example, here, the corresponding letter for A in the other triangle is D. Why? Because A and D are both in the first place in these names. Also, the corresponding letter for B in the first triangle is E, and for C would be F. Each of these letters represent, let's say, angles. We can say first, angle A congruent angle D, angle B congruent angle E, and angle C congruent angle F. We also have 3 congruency statements for sides. Yeah? So we have side AB, yeah? Side AB, congruent side DE. Yeah? We look at the corresponding position. Also, BC congruent EF. And the last one, AC congruent DF. Good. Now, the good news is, in order to prove two triangles are congruent, we don't have to prove all these corresponding parts are congruent. It's enough if we come up with a combination of parts in order to prove 2 triangles are congruent. In this lesson, we'll talk about 2 such combinations. In fact, there are 4 possible combinations of parts, corresponding parts, for triangle to be congruent. As I said, in this lesson, we'll talk about 2 of these combinations. First, we have these 2 combinations, right? SSS and SAS. We're going to talk about SAS a little bit later. But for now, SSS. SSS stands for side, comes from side. So, side, side, side. What does this case state? If all corresponding angles and sides of 2 triangles are congruent, then the triangles are congruent. Yeah? So, if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. In other words, if we can prove the corresponding sides of the triangles are congruent, then the triangles are congruent. Yeah? So, if we look at this example, yeah, we have triangles ABC and DEF. If AB congruent DE and BC congruent EF and AC congruent DF, then triangle ABC congruent triangle DEF. That's the first case. Let's have a few an example with this case, SSS. For example, we have to prove triangle ABC congruent triangle ABD using this case. What is given AC congruent AD. So remember, we have a two-column proof. On the left column, we write the steps needed to prove these two triangles are congruent. On the right column, we write the reasons that justify each step. Good. On the first step, we say AC congruent AD. As a reason, simply is given. Good. Another step is CB congruent BD. Reason, the same, is given. Now, let me explain clearly. Each of these S represent a pair of corresponding sides. Yeah? So, this is AC. We know AC congruent AD. So, let's mark them. AC congruent AD. So, this is so-called the first S in the name. Now, CB congruent BD. CB congruent BD. This is the second pair of sides. Yeah? Let's say S. Now, in order to prove these triangles are congruent by SSS, we need the third S. So, if we can find the third pair of sides, corresponding sides, congruent, we can prove these triangles are congruent. Now, if you look at this diagram, we can notice that AB, yeah, side AB is a common side for both triangles. So, I think it's fair to say AB congruent AB. Why? Because it's a common side. And if this statement is true because of reflexive property of equality. Yeah? We say reflexive property of equality. Yeah? That's the third pair of sides. So, we can conclude triangle ABC congruent triangle ABD by SSS. Good. Now we'll talk about another case or another combination of corresponding parts that can be used to prove two triangles are congruent. And this combination is so-called SAS. Now, what does this case state? If two sides and the included angle of one triangle is congruent to two sides R and the included angle of another triangle, then the two triangles are congruent. Now, what does included angle mean? I will show you a picture to to understand more clearly what does included angle mean. Included angle means an angle that is between two sides. Yeah? So, in other words, this angle is bounded by these sides. So, included angle means an angle that is bounded by two sides, like we have here, right? Good. So, let's go back to our slide. So, let's fill in the blanks. So, if here we have to come up with a pair of corresponding sides. Yep. As we can see, these sides are congruent. How we know they are congruent? Because they are marked with the same number of markings. So, we can say if AB congruent DE, and now we have to come up with an angle. Yeah? So, what is the angle that is included? In other words, included is between these given sides is B. Yeah? So, in this triangle, the included angle is B. In the other triangle, the included angle is E. So, we can say angle B congruent angle E. And now we have to come up with the second pair of corresponding sides. As we can see, BC and EF are congruent. Why? Because they have the same number of markings. We can say BC congruent EF. Yeah? If all these statements are true, then we can say triangle ABC congruent triangle DEF. Now, one more thing. The arrangement of these letters matters. Why? Because this name indicates where we should place the angle. As we can see, angle, this letter comes from word angle, is between sides. In other words, A is included by these sides. Yes? Now, let's have a practice problem with SAS case. So, we have this diagram, and we have to prove triangle GJH congruent triangle HIJ, knowing or given HI congruent GJ and HI parallel GJ. Now, for now, the steps are already written, right? So we have to come up with the reason that justifies these steps. Now, HI congruent GJ. How we know? Because it's given. So we write given. Then HI parallel GJ, yeah, is also given. Now, let's mark these statements. Yeah? So, HI congruent GJ. HI congruent GJ. What else? HI in the same time is parallel GJ. So, we mark this statement by using two arrows. Yeah? Good. Now, on the third step, we have angle GJH congruent angle IHJ. Congruent angle GJH. So, in order to identify this angle, we have to follow the order of the letters. And as we know, the middle letter is always the vertex. So, GHJ is this angle, right? This is one of the angle, and the other one is IHJ. IHJ. I think I marked wrong. Is GJH is this one, yeah? And the other one is this one. Now, how we know these two angles are congruent? What else we know? What else is given? HI parallel GJ, yeah? HI GJ. Now, if these two segments are congruent, HJ is a transversal. Why? Because intersect these two parallel lines in two different points. Because HJ is a transversal, right? These two angles, the marked angles, are alternate interior angles. Why? Because they are on opposite sides of the transversal, right? And are between the parallel lines. What do we know about alternate interior angles? We know always they are congruent, yeah, or have the same measure, yeah. So we can say these two angles are congruent because they are alternate interior angles. Good. Next step, HJ congruent HJ, and it's obvious. Why? Because HJ is a common side for both triangles. Yeah. So they share a common side. And how we know they are congruent? By reflexive property. Yeah? So we have one S, yeah, this is the first S. We have an A, the angle, and we have the second S. Yeah? As we can see, these angles are bounded by the sides. So we conclude triangle GJH congruent triangle HIJ by SAS. We're going to have more applications in a future time. For now, that is all we have for today. Thank you for watching my video. We'll see soon with another lesson.